Good morning. In today's class, we will learn about an experiment which is Andrew's experiment on carbon dioxide. Okay. Now, this experiment was performed by a scientist named Andrews, and he has conducted this experiment just to study the variation of pressure and volume of a given mass of carbon dioxide gas at several fixed temperatures. So he has conducted this experiment just to see how and when a gas deviates from ideal behavior. And after conducting this experiment, he noticed that a gas deviates from ideal behavior when it is near the stage of liquefaction. That is, when a gas tries to liquefies. That is, when a gas tries to change its state from gaseous state to liquid state, it shows deviation from ideal behavior. Now this is the experimental setup that he has used to uh, uh, conduct the experiment. Now let us just explain this figure. See, here you can see two tubes, tube A and tube B. So A and B are nothing but glass tubes having thick walled capillary tubes at the top. See, here you can see thick walled capillary tubes. These are the thick walled capillary at the top. So A and B are two glass tubes having thick walled capillary tubes at the top portion. Now here the width, this in the middle portion, these tubes has got higher width, whereas when it goes towards the bottom, the tube narrows. Then uh, in the tube A, dry air is passed for a long time and then tube A is sealed. Okay, and in the tube B, carbon dioxide gas is passed for a long time and then tube B is also sealed. Okay, that is the first step that we are performing. After that, these tubes A and B are immersed in mercury. After immersing in mercury, the lower portion of the tube, which was sealed, is opened. After that, a small piece of mercury is inserted into the tube A as well as into the tube B. This small piece of mercury will act as a stopper. That is, that piece of mercury will seal air in tube A as well as it will seal carbon dioxide in tube B. So in tube A we have got air, whereas in tube B we have got carbon dioxide. So that is the first step. Then these tubes, you can see tube A is kept inside C1. See the C1. C1 is a copper cylinder filled with water. Similarly, tube B is kept inside C2, which is also a copper cylinder filled with water. Now, these two tubes, that is, the C1 and C2, both of them are screwed by using two steel screws S1 and S2. Now the level of water in C1 and C2 can be adjusted by adjusting these screws S1 and S2. Okay. So suppose that the screws S1 and S2 is tightly screwed. Okay, then this water in C1 and C2 will be compressed. As a result, some pressure is transmitted to air in tube A as well as some pressure is transmitted to carbon dioxide in tube B. Now the C1 and C2 are connected by a crossed tube D. So this is a brief explanation about the experimental setup, which you can read from the following two paragraphs. This paragraph is what I have just explained now. So you can read through the paragraph, or either you can write as what I have already said. Okay. Similarly, as the same thing is written in this paragraph. What I have told earlier is written in all these paragraphs. Okay, so just read through these paragraphs. And one more thing to remind you is that I have already said that in tube A you have got air, and as well as in tube B you have got carbon dioxide. Now in order to vary the temperature of air and carbon dioxide, they are providing a water bath. Okay, that is, there is a water bath surrounding air in tube A. Similarly, there is a water bath surrounding carbon dioxide in tube B. Okay, now before starting the experiment, the water bath surrounding A is kept at a fixed temperature, whereas water bath surrounding B is varied between 0 and 100 degree Celsius. Now, after conducting the experiment, this is the isotherms that we get. Isotherms means a graph that shows the variation between pressure and volume at different temperatures. So since pressure of air in A and that of carbon dioxide in B are the same, then from the volume of air in A, the pressure of carbon dioxide in B can be calculated. That is how the experiment ends. Now the volume of carbon dioxide can be directly read from the tube B, because in the capillary tube you have got markings which actually shows the reading of the volume. Now similar observations are made for different values of pressure. How? By adjusting the screws S1 and S2. Now the same experiment is repeated by keeping the carbon dioxide gas at different temperatures. So at different temperatures you will study the variation of pressure and volume of carbon dioxide gas, and after conducting the experiment you will get such isotherms. Now let us explain the isotherms. Okay, so here see the isotherm AB. The isotherm AB, along the isotherm AB, carbon dioxide exists in the gaseous state. Okay. Now consider the isotherm BC. Along the isotherm BC, carbon dioxide changes from gaseous state to liquid state. Or we can say that along the isotherm BC, both gaseous state and liquid state coexist in equilibrium. And at the point C, the liquefaction is complete. Okay, and what about the vertical isotherm CD? The vertical isotherm represents only the liquid state of carbon dioxide. So that's all about the first isotherm, that is the lowest isotherm is observed at temperature 13.1 degrees Celsius. Now let us consider another isotherm at a still higher temperature, say 21.5 degrees Celsius. Just compare the isotherm BC with that of GF. Here as the isotherm at this temperature, high temperature, you can say that the horizontal portion is little bit shorter when compared with BC, that is GF is shorter compared to BC. This shows that so that is written here. This means that the shorter length of the isotherm shows that density of liquid approaches density of vapor. Okay, at the same time, another difference that you can notice is that see the starting point of the vertical isotherm G, it is at a higher pressure when compared with the C, right? This shows that high pressure is required, that is the starting point of the vertical isotherm G is at a higher pressure when compared with the C. G is at a higher pressure compared with the C. It shows that high pressure is required to liquefy the gas at high temperature. Okay, see it is written there, high pressure is required to liquefy the gas at high temperature. So as we move to high temperature, the compressibility of liquid will be approaches the compressibility of gas. Now let us see the another isotherm that remains, which is the isotherm at 31.1 degrees Celsius. See, in here you cannot see a horizontal portion like GF and CB. Instead, as the temperature is high, that is at 31.1 degrees Celsius, instead of this horizontal portion, or you can say that that horizontal portion you cannot see, instead that horizontal portion reduces to a single point P. Okay, so as temperature increases, you will not observe horizontal portion, that is you will cannot see the horizontal portion of isothermal curve, that instead that horizontal portion of isothermal curve reduces to a point. Here it is marked as P. So this means that further liquefaction of gas is not possible. That is, after that point, volume decreases with increase in pressure. Now, any other isotherms above the 31.1 degrees Celsius, we cannot see any horizontal portion. Everything will be point. Okay, so Andrews found that liquefaction of carbon dioxide occurs only below 31.1 degrees Celsius, and that temperature is called critical temperature. Isotherm corresponding to this temperature is called critical isotherm. The point P is called critical point. The pressure and volume corresponding to critical point is called critical pressure and critical volume respectively. So, the critical temperature, critical pressure and critical volume are together called by the name critical constant of a gas, and they are defined as follows. This session is very important. See, critical temperature Tc is the temperature above which a gas cannot be liquefied by the application of pressure alone. Now, critical pressure Pc is the pressure that should be applied to a gas at its critical temperature to liquefy it. Now, critical volume Vc is the volume occupied by unit mass of gas at its critical temperature and critical pressure. So, study these definitions, this slide very well. Now, results of Andrews experiment is summarized here. That is, there is no distinction between liquefiable and permanent gas. That is, any gas can be liquefied. The only condition is that it should be below its critical temperature. Now, gases like oxygen, nitrogen, etc. can be treated as permanent gas above their critical temperature at room temperature. Okay, that's the reason why we can't liquefy them at that temperature. Now, there is a continuity between liquid and gaseous state of substance. Now, the last point is that as we increase the temperature from a lower value below critical temperature, density of liquid approaches density of vapor, and finally it becomes equal at the critical temperature. So, Andrews experiment on carbon dioxide is an important session. So, just study why this experiment is performed, explain the experimental setup, then the isotherms, and define what are these critical constants, and finally give the results of the experiment. Okay, so study this session very well. So, today this is enough. Thank you.